students, you are welcome to the second segment of number base. In the first section, we were able to explain what number base really is. We also touched on converting from one base to base 10. That's, let's say, from base 2 to base 10, base 3 to base 10. We also learned the vice versa of that. Let's say from base 10 to base 3, from base 10 to base 2, from base 10 to base 5. We also learned converting from one base to another base other than base 10. Let's say from base 3 to base 5, from base 2 to base 6, and many others. We also touched on the operations on number bases, let's say addition, subtraction, multiplication of number base, and we solved several questions to back that. Today we are continuing from where we ended, and that's taking one question under the multiplication of number base. And the question says, evaluate 1, 1, 0, 1 base 2 multiplied by 1, 0, 1 base 2. This is our question. How do we go about it? We arrange it in the form that will be comfortable in multiplying it. And so 1, 1, 0, 1 base 2 multiplied by 1, 0, 1 base 2. With this, we start with it. 1 multiplied by 1 gives us 1. And so we write the 1. Since 2 cannot go into 1 and the remainder is 1, we write it straight away. 1 multiplied by 0 gives us 0. 1 multiplied by 1 gives us 1. 1 multiplied by 1 gives us 1. And we have the base to be 2. We go into 0 multiplying them. You can see that 0 multiplying the number gives you 0. And so we have 4 digits of 0 over here. And so 0 multiplied by 1 gives you 0. 0 multiplied by 0 gives you 0. 0 multiplied by 1 gives you 0. And 0 multiplied by 1 again gives you 0. 1 multiplying this repeats the first section, which is 1, 0, 1, and 1. These are all in base 2. And so we go into the addition of it. As you can see, we started with multiplication of number bases, but we have to apply the addition of number bases over here. And so with the indents or the parts that are left, you can see 1 stands alone. So we can take it as 1 plus 0, of which you have 1. The base is in base 2. We have 0 plus 0 giving you 0. We have 1 plus 0 plus 1 giving you 2. Looking at the 2, 2 goes into 2, 1, giving you a remainder of 0. 1 plus 0 gives you 1, plus the 1 over here gives you 2. 2 goes into 2, 1, giving you a remainder of 0. 0 plus 1 gives you 1, plus the 1 over here gives you 2. 2 goes into it, 1, giving you a remainder of 0. We have 1 over here, and so plus the 1 over here gives us 2. 2 goes into 2, 1, giving us a remainder of 0. Now we have 1 over here, of which 2 cannot go into it, and so it gives us a remainder of 1. And so our answer is 1, 0, 0, 0, 0, 0, 1 base 2 as our answer. The next question says find the product of 1, 2, 2 base 3 and 1, 0, 0, 2 base 3, leaving your answer in base 10. And so with this we have to do the multiplication and convert our answer into base 10. And so what we have over here, we have to multiply them. And so we have 1, 0, 0, 2 base 3 multiplied by 1, 2, 2 base 3. Looking at this, 2 multiplied by 2 gives you 4. 4, 3 goes into 4, 1, giving you a remainder of 1. 2 multiplied by 0 gives you 0, plus the 1 over here gives you 1. 3 goes into 0, giving you a remainder of 1. 2 multiplied by 0 gives you 0. We have 0 over here, and so it gives us 0. 2 multiplied by 1 gives us 2. With the 2 going to multiply this will give us the same thing. That means the repetition of the same thing. So write 1, 1, 0, 2. 1 multiplied by all these will never give us a number that is equal or greater than 3. And so we just have to write the numbers over here down there. That's 1 multiplied by 2 gives us 2. 1 multiplied by 0 gives us 0. 1 multiplied by 0 gives us 0. And 1 multiplied by 1 gives us 1. And so we go into the addition of the number bases. This is in base 3, this is in base 3, and this is in base 3. 1 over here has no, it has indents. So 1 plus 0 will give us 1. 1 plus 1 gives us 2, which is not equal or greater than 3. So write straight away 2. It is in base 3. 1 plus 2 gives us 3. Of which 3 goes into 3, 1, giving us a remainder of 0. 2 plus 0 gives us 2, plus 1 gives us 3. 3 goes into 3, 1, giving us a remainder of 0. 2 plus 0 gives us 2, plus 1 gives us 3. 3 goes into 3, 1, giving us a remainder of 0. So we have 1 over here, plus this 1 gives us 2. 2 goes into 0, remainder 2. And so this is our answer. We have to convert our answer into base 10. We had our answer to be 200,021 base 3. We are to convert our answer into base 10 because they said they need the answer in base 10. That was what the question said. And so we have to number them from 0 up to the last digit. So 0, 1, 2, 3, 4, 5. Since we have 5, we take the first digit, which is 2, multiplied by the base 3 to the power 5, plus 0 multiplied by 3 to the power 4, plus 0 multiplied by 3 to the power 3, plus 0 multiplied by 3 to the power 2, plus 2 multiplied by 3 to the power 1, plus 1 multiplied by 3 to the power 0. 3 raised to the power 5 gives us 243. Multiplied by 2 gives us 486. Plus 0 multiplying this makes it now, that's 0. Plus 0 multiply this makes it now, that's 0. Plus 0 multiply this makes it now, that's 0. Plus 2 multiplied by 3 to the power 1 gives us 6. Plus 3 raised to the power gives us 1. Any number raised to the power 0 gives us 1. Multiplied by 1 gives us 1. And so we have 486 plus 6 plus 1. 486 plus 6 gives us 492. Plus 1 gives us 493. And that's our final answer in base 10. And the next question says, find the value of m if 4m 4 base 5 equals 119 base 10. We all know that numbers written in their raw state are in base 10. And so we can write 119 base 10 as 119. And so we have 4m 4 base 5 to be equal to 119. So all we need to do is convert 4m4 to a base, a combination of numbers in base 10. And so we have to, converting it, we have to take the first one, 4 multiplied by 5 to the power of the number that was given to you, that's 0, 1, and 2. So to the power 2, plus m multiplied by 5 to the power 1, plus 4 multiplied by 5 to the power 0, which is equal to 119. With this, 5 to the power 2 gives us 25. Multiplied by 4 gives us 100. plus 5 to the power 1 gives us 5, multiplied by m gives us 5m, plus 5 raised to the power 0 gives us 1, multiplied by 4 gives us 4, which is equal to 119. 100 plus 4 gives us 104. So 5m plus 100 plus 4 gives us 104 to be equal to 119. And so we have 5m to be equal to 119 minus 104. 5m is equal to 118 minus 104 gives us 15. 5 divides both sides so that we have m to be equal to 3. And that's our final answer. Our next question says, if 136 base x is equal to 76 base 10, find the value of x. Find the value of x. And so we have to convert this into a number in base 10. So we have 0, 1, 2. So we take 1 multiplied by x to the power 2 plus 3 multiplied by x to the power 1 plus 6 multiplied by x to the power 0, which is equal to 76. Since 76 is the same as 76 base 10. X squared multiplied by 1 gives us x squared, plus 3 multiplied by x to the power 1 gives us 3x, plus 6 multiplied by x to the power 0 gives us 6, since x to the power 0 gives us 1, which is equal to 76. We have to take this one to the other side so that we have a quadratic equation and we find the value of x. So we have x squared plus 3x plus 6 minus 76 is equal to 0. And that we have x squared plus 3x minus 70 to be equal to 0. We now have to split this into two terms. And thus, having two digits that when we add, we will get 3. But when we do multiply, we have negative 70. Those two numbers are 10 and 7. 10 has to be positive so that 7 becomes negative, so that we will be able to add and have a number as 3. And so we have x squared plus 10x minus 7x minus 70 to be equal to 0. We have two terms taken into consideration and solving it separately. And so we can factorize x out. And over here, when you factor x out, you have x in here plus x factored out will give you 10 over here. Bracket close. The common term in this is negative 7. And that's factoring negative 7 out of this gives you x in the bracket. If we are to get negative 70 here, then we have to introduce a positive sign here. So the negative 7 times 10 is the one that will give us negative 70. Close the bracket and equate it to 0. And so we have, looking at this, we have x minus 7 and x plus 10 equating to 0. With this, we have x minus 7 to be equal to 0 and x plus 10 to be equal to 0. X equals 7 and x is equal to negative 10. Therefore, x is equal to 7. We did not take into consideration x equals negative 10, since we do not have a negative base. As we learnt earlier on, that number base are taken from numbers that are greater than 0. So numbers greater than 0, you can see there is no negative number in there. So we have 1, 2, 3, 4, 5, 6. That is it. A number with 0 as the base does not exist, since you have 0. And any number with a base 1 gives you 1. Next question says, a number is written as 37 base n. And twice the number is written as 75 base n. And so twice of this gives us 75 base n. And it says we are to find the value of n. Find the value of n. And so we have to change what is in the bracket and 75 base n to a number in base 10. And so we have 2 bracket open 3 multiplied by n to the power. We have to give it a power, that's 0, 1. So we give it a power 1 plus 7 multiplied by n to the power 0. We close the bracket and equate it to 7 multiplied by n to the power. We have to give it a power, that's 0, 1. So it's 1 plus 5 multiplied by n to the power 0. With this, we have 2 bracket open 3 multiplied by n to the power 1 gives us 3n plus 7 multiplied by n to the power 0 gives us 7. Since n to the power 0 is 1, we close the bracket, equals 7 multiplied by n to the power 1 gives us 7n plus 5 multiplied by n to the power 0 gives us 5. And so with this, we have to expand this and equate it to that. And so 2 multiplied by 3n gives us 6n plus 2 multiplied by 7 gives us 14, which is equal to 7n plus 5. We need to get n on one side so that we complete our question. And so we take 5 to this side and 6n to this side. And so we have 14. This coming to the other side gives us minus 5, which is equal to 7n. This coming over here gives us minus 6n. And so we will have 9 to be equal to n. Therefore, n is equal to 9. And that is our final answer. So we take our last question for this lesson. And it says, draw the multiplication table O times. It uses this symbol O times in base 6. It is in base 6 on the sets 1, 2, 3, and 4. 1, 2, 3, and 4. And it says that from the table we should find the true set of 2 O times x to be equal to 2 and n O times n to be equal to 4. And so we go into drawing of the table. We have O times over here. 1, 2, 3, and 4. 1, 2, 3, and 4. And with that, we make our table. One multiplied by 1 gives us 1, which is not equal or greater than 6, and so we write it straight away. The numbers 1 multiplied by 2 gives us 2, 1 multiplied by 3 gives us 3, 1 multiplied by 4 gives us 4. Since the answers over here are the ones that will fill the same place as here, we drop the same answers. 2 multiplied by 2 gives us 4, which should be written. 2 multiplied by 3 gives us 6. But that 6 goes into it 1, giving us a remainder of 0. 2 multiplied by 4 gives us 8. 6 goes into it 1, giving us a remainder of 2. We have 10 and 12 appearing over here, since the multiplication of O times is commutative. 3 multiplied by 3 gives us 9. 6 goes into it 1, giving us a remainder of 3. 3 multiplied by 4 gives us 12. 6 goes into 2, giving us a remainder of 0. And so we have 2, 0 coming over here too, since O times is commutative. We have 4 multiplied by 4 giving us 16. 6 goes into 2, and that is 12, giving us a remainder of 4. And so we go into this part, which says find the true set of 2 O times x is equal to 2. Which number do we multiply by 2 to give us 2? 2 multiplied by 1 gives us 2. And so with this, we express it this way. 2 O times 2 is equal to 2. Let's look into it again. 2 does not multiply any number again to give us 2. And so we have the true set to be x is such that x is equal to 2. And that is since 2 was able to replace x to give us the answer 2. We go into the next one, which is n O times n to be equal to 4. This tells us that we have to get a number that multiplies itself to give us 4. And so 1 multiplying itself gives us 1. 2 multiplying itself gives us 4. And so we express it n O times n is equal to 4. And so 2 O times 2 is equal to 4. Let's look into it again. If we have another number multiplying itself to give us 4. 3 O times 3 gives us 1 3. 4 times 4 gives us 2 4. And so we have a true set to be said that n is said that n is equal to 2. We close our bracket. Since n was able to replace 2 was able to replace n to give us the answer 4. We will release a short video on how to use a calculator to solve number bases, that's changing from base 10 to base 2, base 8 and base 16. Thank you. Subscribe and we will meet again.